Next we discuss refraction by spherical lenses. So what is lens? A lens is a piece of transparent glass bound by two spherical surfaces. The working of lens is based on the refraction of lights when they pass through it. The spherical lenses has two types. One is a convex lens and another one is a concave lens. We discuss one by one. The first, convex lens. It has a two spherical surface. So it means this is a one surface and this is the next surface. The another name of the lens is called biconvex lens because it has a two spherical surface. It is thick at the center but thin at the edges, bulging outwards. The another words that is a bulging outwards. So it is a converging lens. So why it is called converging lens? This concept we discuss later. We compare convex lens and convex mirror. So already we discussed the convex mirror. This is the reflection area. This is the polished area. This is a glass surface. This is a reflection surface. So in these surface is equivalent to this surface. So that it has a two spherical surfaces. So this one and another one is this one. Both have a convex surface. Next, concave lens. It also has a two spherical surface. It is thin in the middle. This is a thin in the middle, but thicker at the edge. So both edge has a thicker. It is a diverging lens. These concepts also we discuss later. Now we compare the appearance of concave lens and concave mirror. This is a concave mirror. This is a reflection area. This is a silver coating area. This area is equivalent to this surface. So this one is a concave surface. The another surface is also a concave surface. It has two concave surfaces, so that it has two spherical surfaces. Next, discuss optical center, principal axis, principal focus and focal length of each lenses. First, we discuss optical center. So optical center means the center point of a lens is known as optical center. So here this is a convex lens, this is a concave lens. Both has a center point, that means O. This is the center point. It is called optical center. So here it is called optical center. And the imaginary vertical line drawn through the optical center of a lens, that means perpendicular to the principal axis. This line is called axis of symmetry. This is the axis of symmetry. So here this is the axis of symmetry in concave lens. So what is mean by principal axis? So principal axis means a line passing through the optical center of a lens, and this is the principal axis. So a line passing through a optical center of a lens and perpendicular to the both of the faces of the lens. Here this is the principal axis. The next, principal focus of convex lens. Let us consider MN is a convex lens. So light travel from infinity distance. That means it is a parallel rays. Here we consider sunlight is a parallel ray because the sun is placed at a infinite distance. So sunlight is an example of parallel rays. Now we take a parallel rays. So parallel rays means so parallel to the principal axis. So this is a parallel rays. Light travel from air to, it is a denser medium, that means it is a transparent medium. So pass through transparent medium. These lines are focused into F2. it is the principal focus. It means a point on its principal axis to which light rays parallel to the principal axis converge after passing through the lens. So all the parallel rays are converged into F2. So F2 is the principal focus. So and in this case light comes from left. In another case we can take light comes from right. So in that situations, so light converge into F1. Here convex lens has two focus point, F1 and F2. Here the two focus of a lens are equal distance from the optical center. So here O is the optical center. The distance between the O and F2 is equal to O and F1. Both are equal. And here 2F1 means already discussed in the convex mirror or concave mirror. So it is equivalent to radius of curvatures. That means let us consider here it has a one surface. We redraw the circle. So here it is the center of the curvature for this plane. In this plane, so we have to redraw the circle in 2 dimension. So we can get a circle. So 2F2 is the center of the curvature in this plane. Next we discuss focal length of a convex lens. Already we discussed the focal point of a convex lens. The distance between the focal point and optical center is called focal length. That means we noted by the symbol F. Convex lens is converging lens because it converges a parallel beam of light passing through it, so that it is called converging lens. So all the parallel rays are converged into this point. This point is called focal point. This behavior is called converging lens. And we discuss principal focus of concave lens. So we take a concave lens, light pass from left side to right side. These lines are parallel rays to the principal axis. These parallel rays are deviated from the original path. So here you can check this is the axis of symmetry. The dotted line is called axis of symmetry. After reaching the axis of symmetry, the light is diverged. Retransmit the diverged ray, we can get the focal point. That means that is a F. It is called principal axis. So here the principal focal of concave lens is a point on its principal axis to which the light rays parallel to the principal axis appear to diverge after passing through concave lens. In the same situations, light comes from right to left. In that situations, imaginary focal point is in the secondary principal focus F dash or F2 we take. So this is a virtual focus for these cases. If the light comes from right to left, this is the virtual focus. So what is focal length of a concave lens? The distance between the optical center, here O is the optical center, and the principal focus of a lens. This is the imaginary focus or virtual focus. These distance, this is called focal length. So it is denoted by the symbol F. So all the parallel rays are diverge. So it is called diverging lens because it diverges a parallel beam of rays. So that it is called diverging lens.